Good afternoon. Manoj, are we expecting anyone else? Manoj, are we expecting anyone else or this is the quorum?
I'm not sure, sir. We sent announcement.
Okay,
So
no worries. This is a long weekend, so people may
yeah,
not be available.
probably.
Yeah, okay, no worries.
But we can expect a few more to join.
Yeah, that's okay. So I plan to anyway do text classification today. Um, and Manoj, is it possible to have one more session next week?
Next week, yeah, sir, we can have it.
Okay, so we can do image classification. This is, we are starting in week 11, right? From tomorrow, from today.
Uh, yes, sir. We'll
Okay.
uh,
Okay,
we'll we'll see how where we can put this content.
okay,
Week
but
wise.
this is week 11, right?
Yeah, this is week 11. Yes.
Okay, so I'll also do image classification next week. Uh, I tried to put it together, but it has not come out the way I wanted. So I will do it next week, but text classification is what is complete, and I plan to present it today.
Mm.
Uh,
So next week there will be OPP. Uh,
it's okay then, Manoj. Maybe Swarnim can join or someone else can join, and we can have a meeting, and not exactly with students, but maybe you and Swarnim can join, and then I can talk.
okay.
Hmm? We can leave. Is it possible during weekday, any day during the weekday, let's say in the evening, 8 to 9 or something like that?
Yeah, possible.
Okay,
Uh,
we'll coordinate. Okay, let me tell you. Maybe towards maybe Wednesday or Thursday we can do it possibly. Hmm?
okay.
Thursday we will try our best to do it between 8 to 9. Hmm?
Yeah, sure.
Then I think the students will be able to join, right? That should not be a problem. Okay. All right. Thank you very much for joining. I know this is a long weekend and Sunday afternoon, but I, yeah, I think this content that I'm going to present will make it worth, hopefully. Um, and last time, right, we started talking about how to do text classification using transfer learning. And transfer learning, as you know, right? I mean, we are using transfer learning as a way to generate features, correct? Because transfer learning is a topic of deep learning and we are not really doing that much of depth of deep learning. So the reason, as I mentioned in the previous class, why we are doing transfer learning is we need to have some kind of a toolkit, right? We need to have a toolkit to um, generate features for text and images, correct? So-called unstructured data. I do not really, I mean, there are some people who do not like to call these as unstructured data because they see that there is a lot of structure in text and images also. So let's call it as maybe non-tabular data or something like that, right? Tabular data is something where we have a bunch of features associated with each example, right? But in these non-tabular examples or non-tabular data, we have every example and then there is either text or image or whatever, right? Depending on the data type. And obviously, right, what we said is machine learning algorithms need some kind of features for every example. And we need to have a way to convert, let's say, text into a bunch of numbers, right? What are those numbers that are representing this text? Or what are those numbers that are representing images? These numbers in general are referred to as embedding, and there are ways to get these embeddings from a given piece of information, either text or image, or of course combination of image and text. That is also possible in the modern parlance of what is called as multimodal learning. So, the recipe is very simple. We are going to take some pre-trained model that is trained on a huge amount of data, and the model architecture and weights are stored with us. And in this case, we are going to use pre-trained model from TensorFlow Hub. TensorFlow Hub is a repository of pre-trained models. And we can pretty much load models from TensorFlow Hub in a very simple manner using a couple of lines of code. And then we have basically the pre-trained model with us. And if you recall, right, the way we are going to function, it's a two-step process. So we have this pre-trained model. What we are going to do is we are going to take, let's say, text. We are going to pass it through this pre-trained model. We are going to get bunch of numbers, and then those bunch of numbers become feature for this piece of text, and we'll be using this feature vector for the text, and we are going to pass it through our standard machine learning algorithm like logistic regression or random forest or support vector machines or naive Bayes classifier for classification problem. You can also take these embeddings and pass it through the clustering algorithm to get clusters of the text. So this is going to be the methodology. The first step is to generate features, and the second step is to apply machine learning algorithm or train machine learning algorithm on this bunch of features or representation or embeddings, and use it to solve the given problem. So in today's class, what I'm going to do is I'm going to take an example of sentiment classification of a movie review. Okay, so all of you must be watching movies, and whenever a movie comes, in theater, we generally look for its reviews, right? There are online reviews, there are newspaper reviews, right? And we decide, right, based on the reviews, whether to watch the movie or not. So here we have simplified the problem. Generally, in real life, we have different stars, right? 5-star reviews, 4-star reviews, 3-star reviews, and so on. But here we will simplify it into two categories, whether the review is positive or negative. Got it? So something like, if movie is getting more than 3-star, it is positive rating, less than 3-star, it is negative rating or something like that. Okay. So we are going to take a data set of reviews, and each review is labeled as 1 or 0, 1 being a positive review, 0 being the negative review. Okay. So we are going to, download the data set. We'll also need a pre-trained model. There are a bunch of pre-trained models that are available. I'll talk about 3 different choices of pre-trained model and demonstrate using one model. And then I'll specifically pinpoint what you can modify in the code, and also try a couple of other models or a couple of other options that are available. And as the best practice that we are following in the code, we will be using pipeline construct. In order to use pipeline construct, we will have to create our own transformer class for pre-trained model. So I have written a sample of that particular code as well. So I'll also walk you through that particular code. So without further ado, what I will do is I'll bring up the collab and start explaining what exactly is happening. And then what you can do is part of the pieces in collab you can copy as they are for your own task, and then experiment with it. Okay, so let me bring up the collab. Okay, is the content visible to all of you? Is the font okay? Okay, I'm taking a minute of a break to just check whether everything is okay. Is font okay?
Yes, sir, it's okay. Perfect.
Okay, you can see it clearly, right? Okay, because this will be part of the recorded session, so I want to make sure that everything is perfectly
Yeah,
fine.
it's good, sir.
Okay, still I have gone ahead and increased font size by 1. So let's see. Okay, um, all right, we'll resume the recording again. So as I was saying, this is a text classification with movie reviews, and it's an example of a binary classification or a two-class classification problem. By the way, this entire notebook I have not authored myself, but I have taken this notebook, part of the notebook from the TensorFlow tutorials. That is the attribution I would like to call out. And TensorFlow tutorials does this end-to-end with TensorFlow, but what we have done is we have taken the initial part where we are using the hub model, and then the later part we are going to use sklearn as we are used to a sklearn model. Okay, so do not worry too much about these TensorFlow details. You can use them as they are for the purpose of this course. Okay, but when you go to, let's say, deep learning course, you can learn about TensorFlow API in more deeper manner. Okay, and just to provide you some idea what is TensorFlow. TensorFlow is a deep learning library, and it has got a lot of neural network building blocks or building blocks for deep learning models. There are models, different optimizers, different evaluation methodology, all pre-packaged and available to you. Just like sklearn, think of TensorFlow as sklearn counterpart for deep learning models. Okay, that much information is good enough for the purpose of this exercise. Okay, and we have what is called as tf.keras API. So I have actually written some part of this text from the notebook as it is, so that you can also see some other text classification guides and things like that. So there is a very nice text classification guide on developer.google.com. So if you're more interested in understanding deeper, deeper understanding of text classification, you may visit this particular link, which I have written for more curious students and audiences. But for many of you, you need not even do this. You can just stick to what we are covering in this course. That is good enough. So we are going to use tf.keras for loading this model from TensorFlow Hub. I was talking about TensorFlow Hub. It's a library and platform for transfer learning, and it has got a repository of pre-trained models. We'll see how to load models from TensorFlow Hub in this particular collab. Okay, I'm already connected to a runtime, and we'll go on, running cells. So here, as a setup process, we are going to do a bunch of imports like NumPy for any of the numerical Python computation. We are going to use NumPy. Then there are a bunch of TensorFlow related imports like TensorFlow, TensorFlow underscore hub, and TensorFlow underscore datasets. TensorFlow underscore datasets is a nice package, just like sklearn datasets, right? We have studied different datasets that are available in sklearn. In the same way, TensorFlow has pre-packaged many standard datasets. So whenever we import TensorFlow underscore datasets, a wide array of different datasets are available to us. Okay. Matplotlib is actually not required for our for this particular collab. I'm going to delete that, and then we will just print few things like TensorFlow version, and we are going to anyway do eagerly execution. This is TensorFlow 2.0, and hub version also we are printing, and for this particular purpose we don't really require GPU, so I'm also going to delete this particular line. Let me run this. You can see that we are using TensorFlow version 2.15. We are going to execute in eager mode, and her version is 0.16. So a small note about eager mode. So in TensorFlow 1, what used to happen is that we used to first tell TensorFlow what computation we are going to do. That phase used to be called as defining a computation graph. And then we used to run this computation graph under a session. Right, so that was in TensorFlow 1, which many people found very unintuitive and very non-Pythonic. So in TensorFlow 2, what they did is they enabled eager mode execution. In eager mode execution, what happens is that as we are typing in the commands, TensorFlow maintains that particular graph internally. We don't have to do this two-step process where we have to first define the graph and then do the training and things like that. Now we can pretty much use TensorFlow like any other Python library. Okay, so that is about eager mode. Do not worry too much about it. I just thought of giving a historical reference to what eager mode is. Okay, we are going to download IMDb dataset. IMDb is, I think, international movie database or something like that. IMDb is also a famous site. It has got all the information about different international movies. So if you are a movie buff, you can go to IMDb, read about movies, right? About a plot of a movie, who are actors, who is director, who is music director, everything about that movie will be there in IMDb. It also has reviews. So this TensorFlow dataset contains bunch of IMDb reviews, and this dataset is available in TensorFlow dataset. So all that we have to do is we have to do tfds.load, just like we do dataset load in Ksggle, and there is tfds.load. And again, the good thing is that you can also see the documentation for this here. That as you hover over this particular thing, you get to see the documentation. So here we are going to, load IMDb underscore reviews. We are going to use two splits, train and test, which is already done in this data set. So which we don't have to really now worry about it. We have set batch size to -1, and we are going to use this for supervised training. So we have set as underscore supervised flag to true. So now we have train data and test data as part of the load function returns train data and test data. And train data, then we convert this data set into a NumPy data set and into NumPy array. And from this data, we get basically uh, a tuple or two different things. One is train underscore examples, which has got reviews, and train underscore labels, which has got the label for every review, right? As I said, this is a binary classification. A review will either be positive, represented by label 1, or negative, represented by 0. And we have 25,000 such kind of reviews. You can see the shape, right, of ND array, 25,000 commas, comma. So there are 25,000 reviews here, and each review has a label. So you can see that for train underscore label, we also have similar kind of a shape, 25,000, right? So there are 25,000 labels here and 25,000 examples. Same way in test dataset also there are 25,000 examples and 25,000 labels. So there are overall 50,000 reviews that are available in this dataset, which is equally split between training and test. And even within this, right, reviews, the number of examples of class 1 and class 0 are balanced, meaning that both class 1 and class 0, right, positive and negative reviews, there are equal number of representation in this data set. So this is that way a simpler data set to work with. We'll run this. Now, if you are loading your own data set, it will be great if you can actually convert it into a TFDS format. If you can convert your dataset into TFDS format, then you will get to use this as it is. Otherwise, you can also use other formats like CSV or some such kind of things, and you will have to read your data using those formats. And make sure that you have one NumPy array that has got the statements or the article, whatever, right? Whatever is your content, the text content, that should be there in one array. So one entry in the array is your entire text content of that example. Got it? So if you have 10,000 such examples, you will have array of size 10,000, where each record in the array will have the entire text content. And then we need to also have then 10,000 labels, right? One label for every example. Got it? So this is how you can repurpose this code for loading any of your data sets. Got it? Any questions so far? Is all good? Okay. Thanks for the feedback. Thanks for the emojis. We'll continue. So this is very important to know how you can use this particular repurposes code base for your own purpose. Okay. Now we'll take a moment to explore the data. Let me run this. And this piece of code, what is it doing? It has printed the number of entries, right? There are 25,000 training entries and 25,000 test entries. And you can see the way it is done. So we use print statement, we say training entries. Then, we left a placeholder again for test entries. We left a placeholder and we used a format function on this string. And we gave the values for this placeholder. The first value over here is length of training examples. This will get filled up here, and length of test examples will get filled up over here. That's how this particular string is generated using the print function. Okay, and if you want to print first 10 examples, this is easy, right? This is just like any other Python program, Python construct for reading entries from array. So if I run this, we will get first 10 entries. Okay. So you can read them, right? So this is yeah, this is one review. This is another review. Okay. All right, I'll take a question. No questions, right? Okay, I got distracted with the ping. Yeah, so you can read the review, right? This is a kind of film for a snowy Sunday afternoon when the rest of the world can go ahead with its own business as you descend into a big armchair and mellow for a couple of hours. Wonderful performances from Cher and Nicolas Cage, as always gently row the plot along. There are no rapids to cross, no dangerous waters, just a warm, witty paddle through New York life at its best. A family film in every sense and one that deserves the praise it received. Okay, so this seems like a positive review, right? You can read this and you can see that this is a positive review. Okay. All right. So these are some reviews that first 10 reviews that we have printed here. So you can go through the reviews and you will be able to figure out whether review is positive or not. Okay. I will also print first 10 labels, and you can see that in first 10 reviews, most of the reviews are negative. There are only 3 positive reviews and 7 negative reviews. Okay, you can see the positive labels to uh, 3 reviews and rest of the others are 0 or negative reviews. Okay, that was a very simple data exploration part. So this is how you generally do data exploration in text. You print bunch of examples, you go through them, and it is important to, one of the advice that I would like to share here is you should go through each of the example and get understanding of how the reviews are written, and then also look at the labels in the training set and see and you can judge yourself, right? Whether the reviews that you read and the label that is given, and do they make sense? Correct? All right, so let's read one negative review. So this is last, right? Sure, this one isn't really a blockbuster, nor does it target such a position. Dieter is the first name of the quite popular German musician who is either loved or hated for this kind of acting. And that's exactly what this movie is about. It is based on autobiography. Dieter Bohlen wrote a few years ago, but isn't mean to be accurate on that. The movie is filled with some offensive content, which is either amusing or dumb. It depends on your individual kind of humor or on you being a Bohlen fan or not. Technically speaking, there isn't much to criticize. Speaking of me, I find this movie to be an okay movie. Okay, so not a great review. So they have given 0 rating, but this could be, this could be hard, right? I mean, while reading this review, I thought sometimes that this is like a positive review, but towards the end, probably this movie is an okay movie. Is kind of a it gives you vibe that probably the review is negative. But this could be a challenging review for on model. Okay, so so you should read through reviews and understand what kind of reviews are they. You can also get an understanding of how big are the reviews, right? What is typical length of the review? So that type of exploration also you can take up. Okay. Now let's come to the model building part, and this is going to be important. Any questions? Yes, Naval, that is correct. So we also need to understand sarcasm or mixed text on online forum. That is totally correct. Any other comments, reviews, any questions? Happy to take up questions because now we are going to descend into the model building, which is the most important part. Okay, so I assume that everything is clear so far. Okay, let's move on. Okay, so we'll be building a transfer learning based model for this task, as we said, right? I mean, the whole purpose of this notebook is to demonstrate how transfer learning can be used for text related machine learning task. So we will need a transfer learning as a feature generator, followed by logistic regression model in Ksggle. We can also use other classification models. So there is nothing particular about logistic regression model, but I chose logistic regression model as a simple model which gives decent result for this particular task. And in this example, the input data consists of sentences and the labels to predict are either 0 or 1. This is what we have already seen. So one way to represent the text is to convert sentences into embedding vectors. We also talked about it. And for that, we will be using models from TensorFlow Hub. So there's a model called Google/NNLM in dim 50/2. So /2 seems to be the version of the model. This seems to be representing English text. So this model is specialized in English text. So that's why this EN and dim 50 means that this particular model generates 50 dimensional embedding vectors. That means for a given piece of text, it will generate 50 different numbers. Okay, so you can try a couple of other options as well. One is again 50 dimensional model, but it comes with a normalization. So in normalization, what it does is it first removes the punctuation marks from the text, and then it calculates the embedding. So when it removes punctuation marks, you sometimes get better better coverage of in vocabulary embeddings for tokens on your input text. And then there is a large model which also uses normalization, but instead of generating just 50 numbers, it will generate 128 numbers, right? So this way you will have a model that gives a pre-trained model that gives you more number of features for a given piece of text. So we'll be using this. I have used this particular model in this collab, but you can try replacing this model with these two models just with a single line change in the code. Okay. So this piece of code is not so important from the from this exercise point of view, but it will give you an idea how we are going to work through this, right? So we are going to so I have stored the model name in this particular string called model, and we are going to use hub.keras layer, and this hub is basically TensorFlow Hub library that we imported. So we call keras layer function on this. We use the model string, then the input shape is empty. We are going to process data which is of type string, and trainable is true or false. So we are going to use trainable equal to false because we don't want to really train this model. We want to use this simply as a pre-trained model. So we can set trainable to false. And then what you can do is once you define this hub layer, you can use this hub layer and pass the training examples to this, right? So here what I have done is I have passed three training examples, first three training examples to the hub layer. And let's run this. And what you have seen here, what you see here is this particular hub underscore layer function has written a tensor. Now, do not really worry about this word tensor. Tensor is like multidimensional array. And this one is actually a matrix because it has got just two dimensions. So the first one has got shape of 3 because there are 3 examples. And for every examples, we have 50 numbers, correct? So this 3 shape of 3, 50 means that there are 3 examples and each example is represented with 50 different numbers. So this is more like a feature matrix that we got. And this particular feature matrix is storing float 32 numbers. And then the number representation is as follows. So you can see that these are first 50 numbers. These are 50 numbers for the first example. Then these are 50 numbers for the next example. And these are 50 numbers for the last example. Getting it? So this is how this matrix is represented. There is this outer bracket. So this is the first entry, first row. This is the second row in the matrix up to this point. And this is the third row in the matrix. Got it? And there are 50 columns. This is the first column. These 0.54 is the value for the first feature, 0.56 is the value for the first feature of the second example. For third example, the value for the first feature is 0.74 or for the first embeddings or first feature. Getting it? This is how this data looks like. Now what we are going to do is we are going to define a pipeline for this. That is our best that is our best practice, right? So I'll skip this particular part for a moment. We'll come back to this, but let's first define a pipeline. And all of you are familiar with pipelines, right? So we are going to use SGD classifier, which is nothing but a logistic regression classifier using stochastic gradient descent. So we import SGD classifier from sklearn.linear_model. And we also import make_pipeline. We have done this many number of times in this course, and you're very familiar with this now. So what I'm going to do here is I'm going to define a pipeline with 2 stages. The first stage is the feature extractor. Second stage is the HGD classifier itself, where we are setting maximum iteration and the learning rate. Okay. All right. Now this text feature extractor is something that we have not talked about. Let's talk about this in more detail. You can see that this text feature extractor is actually a transformer, right? So typically what happens in our pipeline is that we have some pre-processing followed by the classifier, right? So think of this as a pre-processing step. For pre-processing, we use different kind of transformations. So we are going to define a transformation. This is, a custom transformation class. So in order to define this, we have to basically, extend this class from base estimator and transformer mixin. Okay, so this class is inherited from base estimator and transformer mixin. And we have to define basically 2 methods. One is a fit method and transform method. So for fit method, we have not really done anything. So we just return the self. But for transform, we can also return something like empty, right? Or we can say pass. Also, it's like pass. So in the constructor of this model, we are defining the model name. So if you want to, experiment with other model names, just change this model name to those other model names and rerun this particular part. And then we are defining the hub layer. And hub layer is what you saw here, right? Hub layer converts each piece of text into 50 numbers using this model. So we are defining the hub.keras layer. We are using this particular model name. Self.model means we are using this particular string over here and rest of the arguments as earlier. And note that enable is set to false. We don't want to really train this model. Then we don't want to really define the fit function. And in transform, we want to basically call the hub layer on the input example. So whatever input text that we'll give, and this is not just one text, but this is an array of text. Okay, so we will give this array of text, we'll pass it to hub layer, and we'll get a feature matrix out of that. So I'll run this. Now we'll run this. So we have defined a pipeline. And now comes the model training part. Okay, I will actually get rid of this code. This is not required for us now. All right, so now what I'm going to do is, you know how to train the model, right? You have seen this multiple times. Now we are in very familiar territory. The transfer learning part is over. All that we'll do is we will take this pipeline function and we'll call fit. And in order to call this fit, we need to give the training examples and the labels. So give training examples and labels. So note that these are a bunch of text, right? So these are exactly 25,000 text instances that we are giving here and 25,000 labels. So what happens is that in this pipeline, first we convert this text into a feature vector and each text into a feature vector. So we effectively get a feature matrix with 25,000 rows and 50 columns. And this feature matrix is passed through the HUD classifier. Okay. All right. So we use the fit model and you can see the pipeline, right? So the first stage is text feature vector and second one is the HUD classifier. And now that the model is trained, what we'll do is we'll evaluate the model. And we have used this earlier, right? Classification report. Classification report gives us, all kinds of metrics, correct? We get precision recall, F1 score for the classification, and we also get the accuracy here. So you can see that for class able 1, which is positive reviews, we get precision of 0.74, recall of 0.74, and F1 score of 0.74, and accuracy of about 0.74. Okay, exactly 12,500 examples for class 0, 12,500 examples for class 1. There are total 25,000 examples. Okay, so this is how you can, train a text classifier with transfer learning. So what we'll do is we'll now use slightly more, we'll use this particular bigger model and see whether we get improvement in the performance. Okay, so what I'm going to do is I'll basically just comment this line out and copy this. Okay, so we have to get this. More like a URL path. You can actually click on this and you will get to see the model details. Let's actually click on this. So you can see the model card. So this is the model, NNLM, and NNLM is basically token-based text embedding trained on various Google News dataset. So this embedding is trained on news dataset. Okay, and this is called model card, and this is a very useful concept. So model card tells us everything about this model. Okay, it tells you how this model is trained. Okay, it also tells you about different modules in this 50 dimensional 128 dimension. We talked about this, right? 50 dimension ones generate 50 numbers, 128 dimension ones generate 128 numbers or 128 dimensional embeddings. You can see that there are various versions. There is a Chinese model, English model, German model, Indonesian model, Japanese model, Spanish models. Got it? And it tells you how the input looks like, whether it does any pre-processing, how does it handle out of vocabulary tokens, meaning that we will find some tokens which are not there in our vocabulary. How does it handle it? So model card is, I would strongly urge you to look at model cards whenever you're using a particular model from TensorFlow Hub. Okay, it's a good practice. Now we're going to use this model. Everything else stays the same. Okay, now there is some problem. Let us see. Let's see what is happening here. Okay, let me do this. Let me restart the kernel. Run it from the beginning. Let us also try this particular model over here and see if it works. Okay, this is working. This is giving you 120 numbers. Good. Now, let's see why it is not working over here. Okay, I ran this. I ran this as well. Okay, and I'm running this as well. So, okay, so it's still not working. Where is the problem? Should have worked. Okay, so okay, that was the problem. Okay, we will, edit this recording here now. So I'll again start from there. Ideally, this should be self. We should be returning self here instead of pass. Okay. So in order to try the other model, you will have to make a change change over here, where you set model name to the other model that you intend to use, which is 128 dimensional model with normalization. And then what we'll do is we will again run this. Note that we are also returning self over here and we are not doing pass. This is important, otherwise we get run into some errors. And we'll again train this pipeline. So we are training the pipeline is trained, and we'll evaluate the model. Okay, what you see now is the accuracy has gone up to 0.82%. So what happened? Initially, we were using 50 numbers to represent a piece of text. We have taken it to 128 numbers. And now what we are doing is, because of this increase in number of features, we are seeing increase in the accuracy. Do you see this? So this is also consistent with what we have seen in the course, right? So as you increase the number of features, the accuracy goes up in general. So this is what has happened over here as well. Any questions? Any questions? Does anyone has any questions?
Hello, sir.
Yes.
Thanks for the session, sir.
Yeah,
Sir,
session. I mean, I'll cover a few more things, but yeah, no worries. Yeah, tell me.
okay. So I just wanted to know that is there a way if we can know some of the like we have used some abstraction from Google which we do not know how what features it contains and what transformations basically it does. So is there a way to know the explainability of this model that we have built? Like,
So these embeddings are abstract. Okay. There is no meaning attached to them. These are bunch of numbers. Okay. Only thing that you know that if there are two pieces of text that are similar, they will get similar embeddings. That's what we know. Okay, but as such, there is not much meaning that we can attach to each of the embedding.
okay, got it. So thank you.
Okay, so what we'll also do is we'll also try to play with the third option that we have and see how the result change, right? We are going to use now this normalization one. So as I told you, we are going to make a change over here. Let me write one more line. I'll comment this line out. We'll copy this part. This is common thing. The first thing that you should be doing is you should be going to this URL and checking out the model card. We checked out the model card, right? Earlier. Okay. Yeah, the same thing. All right. Now we're coming back to this line. Okay, let's run the feature extractor. Let's define a pipeline. We are rerunning this particular part. Okay, there is no change that we made. I mean, we didn't make any change here. Only change that was made was in this particular transformation code, and we'll train the model. And we'll now evaluate on the test data set, right? So you can see that these are test labels, actual test labels, and these are, we are calling clf.predict on test examples. This is how we get the predicted labels. Getting it? I didn't mention this earlier, so you can see that we are calling the predict function on the pipeline with test examples. So you know, right? I mean, advantage of pipeline is that all the operations are uniformly applied to training and test set. So we don't have any, difference in the way we applied pre-processing steps to training and test with this. And code is also, I mean, the code becomes very compact using pipelines. So we call predict function on pipeline with test examples. So what happens is that these test examples also go through the transformation process. We generate bunch of features for these test examples, and then we pass them through the logistic regression classifier that was trained, and we get the labels for every test example. We compare these predicted labels with the actual labels, and using classification underscore report function, we get precision recall and F1 score for this. So you can see that earlier when we were using the first model, NLLM dash in dash dim50, that time we were getting accuracy of 0.74. Now we are getting accuracy of 0.77. So, just removing punctuation helped you achieve slightly better accuracy, right? And of course, the best one uh, was with this particular model. So this one, we achieve slightly better accuracy than this, and this one is even more, accurate. Okay, so this is the best. This model gets us the best performance. So this is how you can, play with different pre-trained models and select the one that works well for you. So this is, in some sense, also parameter models that are available there. Right, so you will have to, only worry about, generating too many numbers. If you generate too many numbers, you might start overfitting. So that is what you need to be watch out. You should be watchful about. Okay. So that's all from this particular session. So a quick recap. So what we did is we took the movie review dataset and we tried to build a classifier. So movie reviews are in English text, and we took that text dataset. We converted that text dataset into a bunch of numbers with the help of pre-trained models, and we saw 3 pre-trained models, and then we used logistic regression classifier on top of these numbers to classify review as either positive or negative. And we use these 3 different pre-trained models, and we saw the effect of these pre-trained models on the accuracy. Okay, so if you are going to do any of the text tasks, you can please copy this particular collab, and all that you need to make change in the way you are reading the data set. So that is also simple. So you can read data set which, let's say, is in CSV format, and have train examples and train labels loaded from CSV format. So load that data, then divide this into training and test. Then you will have train examples, train labels, test example, test labels, and we have done this multiple times in the course. And then you should explore it a bit, data, to understand what kind of text is there in the data set and what are the labels that they're getting. You can also look at the length of each of the text, and then it's all about building the model. You can pretty much retain this code as it is, except for the change of the model. And then use pipelines, train the model, get predictions out of the model, and use classification report to get the quantitative numbers for the task. Okay. So that's all from this session. In the next session, we will be doing the similar exercise of using transfer learning for representing images. Until then, goodbye. Thank you. Okay, all right. How did you find this? Any questions?
So, the problem of generating embeddings we have been able to bypass by using this. That zero
No.
padding thing that we are doing, that zero padding is still not
Okay.
coming again. I tried that day, but my code runs out of memory every time on Collab and Kaggle.
No, this is easier to do it, right? Last time we were trying to do lot many things, and those things are nicely abstracted in this TensorFlow hub. So with this hub.keras layer, we have bypassed that problem. The keras layer takes care of all the low-level details that we are trying to take care of. So we don't have to really worry about that as as beginners in this particular field. Right, so embeddings are still getting generated, but those embeddings are getting generated in a more user transparent manner or in a more friendlier manner. I'll share the link to the code. Yeah, go ahead. Any other question?
So one question,
Yeah.
sir, why are we calling this as transfer learning?
Uh, we are calling this as transfer learning because it uses some pre-trained model, right? And we have seen there are three ways of rather there are the way you do transfer learning. There are two ways, right? You can either use the pre-trained model or the model that was trained on some other task as it is to generate the embedding. So we today we use a model that was trained on Google News dataset, and we use that model to train our embeddings, right? So here we are using that model as it is. We are not making any changes to that model. Second way in which we can take that model, change some of the last few layers or something like that, right? So we talked about some of the fine tuning or using fine tuning for doing transfer learning and things like that. So here we are using, I call this as transfer learning because we are using the model that was trained on some other task for generating embeddings, and we repurposed it for our own usage. Does it make sense?
Yeah, yeah, understood, sir. Thank you.
Okay. Now you can try. You will get access to the notebook. Indranil, can you try it again?
Yes, sir. Now I can access. Thank you.
All right. Any other questions? All right. Thank you for your questions and patiently listening. How was the session? Is it accessible? Is it
The
natural
session.
enough? Is it natural enough, or is it too artificial and
So you would need to solve the captcha on the screen for us to know that you are real or it's your avatar speaking.
yeah, exactly. That's what I wanted to ask, right? I mean, this is not too robotic, right? It actually helps to have some people online, because then you know that you're talking with some real people and not to the camera. All right. So thank you very much. I hope this will be useful for your fellow students. Okay. Take care. Have a nice
Any
evening.
homework, sir? Any potential homework that we
No,
can
you
try?
you can try same thing for maybe try a few other text classification tasks and let me know. So I told you that you can make few changes and pretty much use this as it is.
Hmm.
So get some other text data sets and try to see if you can use this method. Okay.
Okay. Any potential Kaggle challenges where this would be good,
I am
useful?
sure. Let us check it out. No, I mean I don't have anything offhand, but we can go to Kaggle and search for text classification. Oops. For multi-label text classification. Specific. Medical symptom text and audio. You can try this fake news. Hmm?
Okay, sir.
You can try this fake news classification task. Uh, I'm not sure you can. By the way, I mean, don't get disheartened if you don't get great results, because this could be a very tough problem. Just going to share the link. But I really want, Naval, if you can actually try it, or someone else also, if you can try this particular data set, and give me
Sure, sir.
give me feedback whether the whatever I have said in the class, whether you are able to do this with those tricks and tips.
Sure, sir. Will do and reward. I tried the last homework. I thought it's the issue with the memory that the
Yeah,
free.
that's okay. Last homework was not really homework. I mean, I just requested some help from your side
Yeah,
to see. Then there are some other challenges also. There's something called as SMS spam detection dataset.
yeah. I'm using that only, sir.
So you can try SMS spam detection dataset as well.
Okay. So I guess the first challenge would be converting that to TFDS, and
No, no,
once
no, 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 no. Don't go for converting that to TFDS. What I'm saying is that straight away read it in CSV. Hmm?
okay,
And yeah, that's what I'm saying. TFDS would be a lot of effort on your end. It may not work. So what I said, right? What do we need? We just need these four things, right? Train example, train labels, test example, test labels, right? So you first read all the examples and labels with a CSV parser. So simple CSV file, right? Okay, wait, sorry, so here, right? So we have in spam data set, uh, here you have V1, right? Spam and ham. So this is label and V2 is actual spam, actual text, right? So you can read this CSV file and just select these two columns. So this is label and this is text, correct? Then what you do is you you basically do some kind of shuffling of this data set and split it into training and test. Okay.
yes, sir.
Then you get training examples, training label, test example, test label. You get it,
Yeah,
and then run with it. Don't convert it into TFDS. That would be too much of work. And we have not talked about it. We have not covered it. So I don't want you to go through that hardship.
okay. So one more question. So in today's example, you split the train and test exactly into 50-50%, 12,500, 12,500. Was that
Because
intentional?
I actually took the split that was done in TFDS, but you can do 70-30.
Oh, it's not that it will produce good result only
No, no, no,
using
no, no,
50-50.
no, no, no.
Okay,
Idea is to use a lot many examples for training. So 70-30 would work well, 80-20 will also work well.
okay, sir.
But that doesn't mean you should have less example for test. Test should also have good amount of examples so that you get correct estimate of the performance. If you use too few examples in the text, then that's not a good estimation of the performance of your classifier.
Yeah, I agree.
So is the recipe clear? So you will read this SMS text dataset in CSV format. Okay.
Yeah,
Shuffle it, do random shuffling of it, right?
okay.
And then take first 70% examples as training, later 30% examples as test. And then from there you split, right? You say that what is training label, what is training text, and things like that. So do whatever way that is convenient. Hmm? And
Yes, sir.
let me know. I mean, what I can do in the next class is that first I'll show how to do it for any generic data set,
Sure, sir.
maybe with spam or something else. So if you actually do this, share your code snippet with me before
Sure,
the
sir.
class.
Okay, sir. Yeah,
All right, because this is important. See, I mean, you should not. So the way I have set up this particular notebook is that you don't have to make a lot of changes. It should
yeah,
work out of the box, and
yeah,
you should not be. You should not. You need not worry about TensorFlow. You should not go to Hub and things like that.
yeah.
Um, it is enabling you to process text data set. That is the whole purpose of this week 11 and 12. You should have enough tools in your toolkit to deal with text, images, audio, those type of data sets.
Yes, sir.
Hmm?
Yeah,
Okay.
yeah.
All right. Take care. Bye.
Thank you, sir.
So remind me, huh? So next week I should basically giving you one code snippet to convert to basically read any text data set
Okay.
using CSV file,
Hmm.
and then rerun this, right? We will spend first 10-15 minutes doing that, and then we'll go to images. Okay.
So one more question, if I may.
Hmm.
So this is a competition which is there on the Kaggle. I was actually going through this.
Hmm.
This is AI assistant for data tasks with Gemma.
Huh.
Earlier, so in the future, will the ETL work or the entire 80% of the hard, you know, lifting heavy work, those work when you do the ETL, clean data, parse data, will that be mechanized in future? Is there no requirement of any humans in that? Because this Google competition wants, I guess, ETL to be done through AI. ETL and cleaning, I guess,
Huh.
and enriching also.
Yeah. So if you do it,
I was thinking, should we contribute or and outwork ourselves, or should we keep ourselves in the job and not participate here?
no, no, nothing like that. I mean, whether you participate or not doesn't going to change the
Someone else will
outcome.
build it.
Yeah, there is no change in the outcome, whatever, right? I
Yeah,
mean, there is no point in fearing these AI tools,
yeah.
but try to see how you can make friends with them and make maximum use of that for increasing your productivity,
Yes,
right?
that's correct.
I would say that if you use your human experience and if you do data pre-processing on your own, right?
Yeah,
AI will definitely benefit from your experience because you are doing this pre-processing based on your experience.
yeah,
So you it will definitely be beneficial. But again, right, you should first try the model without doing any of that, right? Your baseline model should be using all the off-shelf libraries and checking out if how things are working out. And then you go and apply your own experience, intelligence
yeah.
into pre-processing and again check whether there is any change in the results, right?
Hmm.
That's
Correct,
how we should proceed.
correct, sir. Okay.
So building baseline model is always important. I also, I have also stressed enough in the course, right? Throughout the course, I was saying that build first the baseline model
Yes.
and then do other things on top of that. That way, you also get to know why certain things are working in the model.
So the baseline model and dummy classifier are usually same, right?
No, no, dummy classifier is not a very strong baseline. It's a very weak baseline as such.
For example, in this case, when you could have only configured as 0 and 1, and if your accuracy is
Yeah,
82%,
we could have said 50% accuracy, right, with
yeah,
dummy classifier.
yeah. So you have actually improved only 32% by 128-bit.
Yeah. About 32%, which is huge, which is a big deal.
Which is huge. But usually people think 82, they think a big number, but they don't realize that 50% is the baseline. Because random will get 50% anyway.
Sorry, no, come again. My internet was unstable. What were you saying, Naval?
So the 82% looks very big number for the beginners, but when we understand that the baseline is 50%,
Yeah.
then the increment is very big. But
Hmm.
of course, it's
Yeah. So that's why
base is 50.
dummy classifier is very weak baseline as such, right? You can also build some more stronger baseline. Here, I would say stronger baseline is what we tried earlier, right? With 50% thing, right? So we got 74% accuracy without doing much. So I would say that is a stronger baseline. Now you try different tricks and see how much more you can lift it. This particular classifier generally gets sentiment classifier gets generally up to 95% accuracy. Okay, so we have still some more gap to close. So maybe that is a challenge to you folks. Can you actually improve the accuracy further on this particular pipeline?
Yeah, and the incremental
Try.
effort compute needed for the incremental accuracy, that would be the trade-off, I guess.
You
If-
can actually try
yeah,
ensemble approach. You can try random
yeah.
forest classifier.
So
You
when
can
in the
try
Kaggle competition,
something like boosting.
in the Kaggle
Huh?
competition, sir,
In
when
Kaggle
we
competition also the same.
so when
Go ahead.
in the last term when we did that sentiment prediction on movie reviews, I cleared data science diploma before. Have already cleared. When I tried
Hmm.
that, I developed like 10 plus models, and to my surprise, I used decision tree and everything you can think of. And to my surprise, the best results came from logistic regression. The simplest one is usually giving the best result, and not the
Yeah.
all the fancy stuff didn't give me get highest
Yeah,
score in the
yeah,
Kaggle
yeah, yeah.
leaderboard. Yeah.
Nice, nice, nice. So that is important. Yeah, try simple models. There is no point in trying something very fancy models because every problem is different in machine learning, right? So try with simpler models. If they're not giving good results, then only go for that. So idea is doing it very iteratively. So whenever you get data, right, for a competition like Kaggle, you should set aside some validation data set and then go on building model. When you build model, then you evaluate it against the validation data set. And then when you evaluate it, right, do error analysis also, right? Find out which examples are getting misclassified and try to come up with hypothesis why they are getting misclassified. Try to see if you can actually add some more features, right, based on those. And one idea is to try more features, then try different classifiers, try ensemble, try boosting style classifiers, and see how what really works. So it has to be incremental, and there should be a systematicness in the experimentation. You should also maintain your experimental log, right? You can say that step one, these features were tried. This classifier was tried with this configuration. This was the pre-processing. These were the pre-processing steps that we tried. And what was the result, right, of that? Whatever metric you're tracking, you should write it over there. And you should literally maintain a log, like a journal log. This is more like the way you do science experiments, right? So we should also have
Yeah.
a way of
Just thinking of
uh,
it's appearing like a titration experiment. Added that many milliliter.
exactly. Exactly. And there is no simpler way. Only simpler way is to use a lot of compute and set up a hyperparameter tuning job, where you can put all classifiers, all kinds of settings for them, and do a very large, cross product of it and train some 500 variations. But you will still need to figure out, right, how things are working out. When you automate, of course, you'll get productivity boost, but you will miss out on that important experience, down what works, what doesn't. And there is no fixed recipe for this, unfortunately. So that actually opens up a lot of brain cells for creativity. So there is no dull day for while doing machine learning experiments. Okay.
Sir, for this particular competition, for this particular task, when
Hmm.
we are loading the data into TFTS, before that, can we use some NLP techniques like removal of stopwords or
Yeah.
any in-gram language modeling? Can we do that? Then perfect.
Don't remove stopwords and things like that because now the way these models are learning, right? I mean, you're giving entire sentence and they're trying to make sense of that using those entire statements. So don't try to remove stopwords, but you can experiment and see what happens when you remove stopwords, right? Probably, I don't know what would happen. We need to really see, right? But
Assignment
whole
might.
idea, right? As far as this course is concerned, right? I don't expect any of this from the people who are attending this course. They have no idea about how NLP works. What are different pre-processing techniques in NLP, right? So without even knowing anything, any of these things, how can I empower these students to deal with text data? That was the main objective of covering this content. It is not we don't want to cover the breadth of topics in NLP in this or breadth of topic in image processing. These are huge topics in itself, right? I mean, each of these image processing, speech synthesis or speech recognition, computer vision. These are big topics in itself. But I mean, I have a very simple, abstraction in our mind, right? I mean, all these topics, what are they doing really, right? They are taking these different type of data sets and converting them into bunch of numbers so that machine learning algorithms can consume those features. Correct? So see what NLP does. NLP has bunch of techniques how to convert the text into the numbers, and these numbers will be different. I mean, a vector of numbers will be more efficient if you do some more intelligent job in that NLP processing, right? Depending on your experience. But none of that is accessible to our students who are doing MLP and MLT for the first time. So, we were discussing among ourselves, right? I mean, though this is first introduction to machine learning, practical machine learning course, right? But we are only covering tabular data sets. We are not really empowering students to get information. I mean, we are not really giving tools to students to process data sets like text, images, audio, right? So that's why these week 11 and 12 content are being again recorded. So we thought that transfer learning is a very simple tool that can be used for all of these things. And because of that, I'm not emphasizing on all stop words, punctuation, and nothing of that sort. We are saying that bring your text, use this model, get representation. And now, once you get representation, you can try different machine learning techniques on top. Right. So we are solving a very simple representation problem.
Yeah.
Got it? In the context of this course, I mean, I don't want you to do any of these things, but if you're advanced NLP user, you can do many more things aside beside this.
So that if we use TF-IDF, then automatically because the stop words frequency will be higher and they will be used across multiple data sets, so the IDF will automatically come down because TF-IDF
Yeah,
figures
yeah,
out
yeah,
which words
yeah,
are
yeah, yeah,
particularly in which particular area. It automatically identifies frequency and
yeah, yeah,
inverse. Yeah.
yeah, yeah, that's correct.
Earlier we used to drop the stop words and those.
Yeah, so many things we used to do. I mean, there used to be quite a pipeline, right, of pre-processing tasks on these things. But then you also needed some very specialized knowledge of those topics, right? For the student who is doing first time NLP, they don't have any of this knowledge. So the easiest that they can do is to use transfer learning and do this. I understand there is a gap, but this is the easiest tool that I can give it to the students.
So what is trending in market? Like what is been used in production level systems? Same technology or better technology?
Yeah, now everybody is using embeddings. Everybody is using generative AI embeddings. These are all standard things now.
Okay.
Yeah. So learning, transfer learning is has got a huge value. Understanding transfer learning has got huge value, even in practical way. Nobody trains models from these big models from scratch. Everybody tries to do transfer learning.
Any good books for TensorFlow apart from the Google's one,
Uh,
or the documentation only, online documentation?
Documentation is good. Documentation is good. I would suggest don't really study any of these TensorFlow, PyTorch, or JAX. So read. I mean, I would suggest study Keras 3. Keras 3 is amazing. Keras 3 is a wrapper over all these frameworks. So you can just select a backend, write the code in the same way Keras converts that into the respective framework.
Okay.
Sir, you are teaching one course in NPTEL, right? So
Yeah, yeah. So I taught TensorFlow 2, right? I We
yeah.
have actually discontinued that course because TensorFlow versions keep changing.
Mhm.
And then it was a bit challenging, right? I mean, if I teach a course on TensorFlow 2, right? 2.0102, for example. Next semester,
Mhm.
when students are trying it out, right? They have TensorFlow 2.05. Certain things work in a different way. So there was a lot of discrepancy. I'll re-record that course for you with Keras.
Yeah. That will be really great because once we move from MLP to some advanced things, whenever we're going to the industry, they are asking us for TensorFlow or some PyTorch knowledge.
Yeah,
But
I'm actually going to, I'm actually trying, I mean, I was proposing similar kind of course, right? The way we have NLP course, right? I was proposing
yes,
similar course for deep learning, a practical deep learning course,
yeah, yeah,
where we'll just be taking problems and solving them using Keras or something.
yeah, that would be really great. Deep learning right now, I think it's completely theoretical course.
Yeah, yeah.
So that would be great.
We'll try. We'll try. I mean, recording and preparing content, it's a huge effort. But again, we have students like you and we have very able instructor. We can actually pull it off. We'll see. I'm first trying to stabilize MLP. Once this is stabilized, we will move to that.
Yeah, sure, sure. Thank
All
you, sir.
right. Okay. Thank you very much, folks. This was very great. This was great talking to you. And thanks for helping me record course by talking to live people. Okay.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you,
Take care.
sir.
Bye.
Happy stuff.
Yes. Bye.
Bye. Bye. Happy